Introducing Nova, a fully onboard, object-centric framework that enables robust target tracking and collision-free navigation using only a stereo camera and an IMU. When tracking targets in the wild, multiple challenges emerge. A dynamic target may enter buildings where GPS becomes unavailable. Sudden lighting changes can cut features, making detection and depth unreliable. Visual distractors interfere with target association. And in constantly changing environments, map-based approaches become fragile or too expensive to maintain. Nova addresses these constraints directly. It avoids global localization altogether and instead plans motion relative to the target, using only onboard sensing. To do this, Nova combines two core perception streams. First, it detects the target in the stereo RGBD image and estimates its 3D position relative to the drone. In parallel, the depth image is completed and used to identify high-risk obstacles in the current field of view. These two perception streams feed a nonlinear model predictive controller that generates short horizon trajectories, keeping the drone close to the target while avoiding collisions. We evaluate Nova across a wide range of conditions and environments. The first set of tests focuses on static targets. Here, we place one or more mannequins in a simulated search and rescue site with cluttered and uneven terrain. In one scenario, the target lies on a wrecked vehicle surrounded by debris. In another, it's placed on top of a container, requiring the drone to ascend and maintain a stable position from above. We then test Nova in high-speed dynamic pursuit scenarios. In these experiments, the target is mounted on an ATV and driven along long gravel paths at speeds exceeding 50 km per hour. As the ATV accelerates, turns, and kicks up dust, the drone maintains formation by continuously adjusting its trajectory based on the relative pose estimate. To evaluate Nova in more complex, full-scale missions, we run 4 long-duration flights across varied terrain. The first mission takes place in a container maze. The environment is flat, gray, and untextured, with minimal visual cues for depth or tracking. Poles, fencing, and a wrecked vehicle act as fixed obstacles. The second mission starts in an open gravel lot, enters a large metallic hangar, and returns outdoors, introducing severe perceptual disruptions. Nova holds continuous lock, rejects distractors, and maintains smooth control throughout. The third mission covers over a kilometer of unstructured forest trail at high speed. The ATV reaches over 53 km per hour as it drives through varying terrain, foliage, and changing light conditions. The ground is uneven and dusty, and visibility is frequently interrupted by branches and turns. Nova must track in real time while planning safe paths without a map. In the final mission, Nova is tasked with maintaining a fixed vertical offset of 6 meters above the target, simulating surveillance-type behavior where the drone must track from an elevated perspective. The full path includes outdoor flight, a pass through the metallic hangar, a gravel transition, and re-entry into the container maze. At this height, stereo depth becomes less reliable, the target appears smaller, and obstacle awareness becomes more constrained. Across all experiments, Nova maintains stable target lock, plans feasible trajectories, and avoids obstacles in real time. To the best of our knowledge, this is the first demonstration of real-time, high-speed, object-centric navigation that operates fully onboard and in the wild, without external infrastructure, explicit mapping, or dependency on structured priors.